Alright friends, so in continuation of what we had been learning under normal distribution in past couple of classes, now in this class we are going little deeper into normal distribution. So more or less you have understood how to identify the required area under normal curve. But you know what we have done in the earlier classes? We have purposely taken up examples where the z value is coming exactly +1, +2, +3 or -1, -2, -3 or 0. What if z value is a fractional value? Then how to deal with that? For that you cannot remember the probabilities, and as a result you might have a need to refer to z table. Now we have three different versions of z table, and which z table how you should use and which one will be more convenient at what situation, that also we will understand. But your comfort should be in dealing with any kind of z curve or any kind of z table given to you. So if a z table is given to you, I told you there can be three different modes. One could be area from 0 to z, area from 0 to z. Another could be area from that z value to the extreme right or to the extreme left. That means you can have three different types of z table, and suppose you are referring a particular z table, you should be clearly aware of how to use that particular z table, and you should not have a confusion over there. So two things you need to understand: how to identify the required area under normal curve, which I believe you are more or less very clear, and which z table you should refer over there, and how to exactly refer that particular z table. So suppose as an information what comes to you could be any of the three types of z table. You should have complete comfort in handling that information about z table, which kind of z table is informed to you, and how you are going to use that information in attempting your solutions to questions. So in continuation of normal distribution, I am going to take another example in today's class, that will be example 5. Till previous class we have completed 4 examples. Let us focus on example 5 now. It says the returns of a stock are normally distributed with a mean, that is mu, of 15% and standard deviation, that is sigma, of 12%. What is the probability that the returns will be between 12% to 18%? Now, when you are attempting the solution, probability that the returns will be between 12% to 18% is what you have to figure out. First thing what you will have to do is to find the z value. Now please observe one thing, that the mean return is 15%. So if I want to find the probability of returns being 15%, it will come at the center. You know it very well, because the center is the mean. How far your deviation is from the mean is based on the z value being either negative values or positive values. To this area under normal curve, if you can focus, you know one thing very well, that this is the center, this is the normal curve which is symmetric to the center. What you find on the left is the same what you find on right. The left side is covered by negative values of z, the right side is covered by positive values of z. The z values can go from extreme negative infinite to positive infinite. Now how would you figure out what is the required area under normal curve to attempt this particular solution? Point is, you need to compute the z value. Now use your common sense. How many z values you are going to compute if you want to find the returns between 12% and 18%? You want to find the probability of returns between 12 and 18%. Can we agree that you are supposed to compute two different z values? One where the x will be 12 and one where the x will be 18, because mu is defined 15% and sigma is defined 12%. And how do you compute Z? It is x minus mu divided by sigma. So what I am going to do, I am not going to separately give you time to write down the solution. Along with me, you also solve this in your notebooks. So let us begin with the solution right away. We first compute the Z value. So I am going to write, in fact let me expand the screen size for your reference. So I am going to write Z equals to x minus mu divided by sigma. So for 12% return, it will be 12 minus 15 divided by, what was the standard deviation? Standard deviation was 12, right? Standard deviation was 12. So it is 12 minus 15 divided by 12. These values are in percentage. 12 minus 15 will give you minus 3. Minus 3 divided by 12 would eventually give you negative 0.25. Now, for Z value at 12% return, it is negative 0.25. Let us find it for 18%. So the formula remains same. The x value will now change to 18%. So it will be 18 minus 15 divided by 12. It will be positive 3 divided by 12, and that comes to positive 0.25. So you know what we are going to do. We focus on this normal curve and we identify that somewhere over here, suppose it is negative 0.25, somewhere over here it is positive 0.25. We want which area? We want which area is the question. So the point is, I would just draw this over here and over here, and what will be known to us is the area from 0 to Z. So look at this, this is the shaded area, which is area from 0 to Z. Now look at one thing, we will have to refer to a Z table to identify this area. We will have to refer to the Z table to identify that particular area. Now which Z table we should refer? So let us first observe what are Z tables available to us. So let me leave this aside and take you to the Z table. Look at this. The type of Z table that we have over here, Z table, that is area under normal curve from 0 to Z. This is from 0 to Z. That means the table is indeed giving you the area. See, look at this, look at this. This is 0 and this is the Z value. So you are actually getting this particular area, that is area from 0 to Z. That area is what you are getting. So let us observe what is that area and how to find it out. So we want Z value to be 0.25. So learn how to refer to this Z table. We want to identify where comes 0.25. So in the column heading of Z values in the Z table, you identify, because you want 0.25. So you come to this 0.2, and if you refer to this, it is 0.00. So 0.20 and 0.00, that combination will give you 0.20. 0.20 and 0.01 means basically 0.01 added to 0.20 will make it 0.21. So if I want 0.25, I have to select this particular column 0.20, and I'm sorry, I should not say column over there, it is a row, that particular row specifying 0.20 as the heading, and the column will be 0. This particular column 0.05. Now let us see the intersection point of this. the intersection point of this 0.20 and 0.05, the intersection point is this. So what I'll do is I'll just highlight this particular cell and it will be 0.0987. So what is the area under normal curve from 0 to z, where z value is 0.25. Look at this intersection where z value is 0.25. The area under normal curve from 0 to z, that is from 0 to 0.25, is 0.0987. So I'm sure you have understood how to identify that area, 0.0987. Now let us get back to our solution. Here it is. Now I am going to write over here. Let me expand the screen size for you so that you can focus only on what I am writing. So now I'll write over here in detail. Area under normal curve from z equals to 0 to z equals to 0.25 is how much it was? 0.0987. Correct? Let me just cross check, once again double check so that we are not picking any wrong value. It is 0.0987. Perfect. 0.0987, that's the area. Now which area is this? It is the area under normal curve from z equal to 0 to z equal to 0.25. That means if I focus on this, this is the area and this area is given as 0.0987. So now logically, if I write one more line over here, from z equal to 0 to z equal to negative 0.25, obviously it is going to be the same, that is 0.0987, correct? So this particular area, it is 0.0987. So even this area is going to be the same value, 0.0987. And to identify that probability that the returns will be above 12% but up to 18%, that is returns will be between 12 and 18%. If you need to find that particular probability, you need to find this entire area you need to find, which is aggregate of 0.0987 and another 0.0987. So if I pick the calculator and take 0.0987 plus the same or just multiply by 2, what I get is 0.1974. So I would say therefore area from z equal to negative 0.25 to z equal to 0.25, that is positive 0.25, will be 0.0987 plus 0.0987, and that is coming to how much? 0.1974. So we can conclude, therefore probability that the returns will be between 12% and 18% will be 19.74%. This is your final answer, 19.74%. So just make sure that you have written this whole thing systematically. That was the answer for example 5. Example 5 has just asked one thing: what is the probability that the returns will be between 12% to 18%, and we have answered that. The final answer is 19.74%. Now let us move on to example 6. Example 6. The returns of a stock are normally distributed with a mean mu of 15% and a standard deviation of 12%. Similar information. What is the probability that the returns will be below 9%? What is the probability that the returns will be above 9%? What is the probability that the returns will be below 3%? And what is the probability that the returns will be negative? So one by one we are going to answer each of these. So getting started with the solution to example 6. The first part of that, let me mention that this is the first part. First part, probability that the returns will be below 9%. Now what we are going to do, tell me? You know what you should do over here. You have to first find the z value, right? So we always write z equals to x minus mu divided by sigma. So what is the x value over here? 9. So it will be 9 minus 15 divided by 12. That is going to be 9 minus 15 is what? Minus 6, and minus 6 divided by 12 will be negative 0.5. Obviously negative 0.5 will come where? To the left of the curve, right? So let us identify, say it comes somewhere over here, negative 0.5. Now once you identify where comes negative 0.5, what you need to do is, you need to understand the question is asking you probability that the returns will be below 9%. That means this is the 9% range. So probability that the returns will be below 9% will be this area, correct? So we want which area? We want the area from z equal to minus 0.5 to the extreme left, correct? To the extreme left. We want this area. How do you find this area? There are two different ways. I would say you pick up the z table, which will give you area under normal curve from 0 to z. Now 0 to z, as in 0 to 0.5 or 0 to negative 0.5 will be the same thing, because the curve is symmetric. That is the advantage of symmetry. That is why when you are referring to any z table, the row and column headings you will never find as negative values. It's only positive values over there, because once you get the positive value area, you get the negative value area as well, because the curve is symmetric to the center. Now I can do one thing. I can refer the z table and identify this red color area, which will be area from 0 to negative 0.5 or positive 0.5, anything. Once you get that area, then we also know that area from 0 to extreme left, correct? That is the whole area below 0, correct? I am talking about this area, the whole area, the red and blue taken together is going to be having area of 0.5. So from 0.5, if you subtract this red area, you will get the blue area, correct? That is one way. So let us first do that. I take you to the z table. Now see, we want z equal to 0.5. So z equal to 0.5 is directly, so it is 0.50, right? Look at this, z equal to 0.5, this will be your required area, having area under normal curve as 0.1915, correct? 1915. Now which is this area? We be very clear, it is area from 0 to z, that means area from 0 to 0.5. So, but I am not going to write area from 0 to 0.5, I will write area from 0 to negative 0.5. So, let me write that thing and let me expand the screen size for your reference. So, I will write here area under normal curve from z equal to 0 to z equal to negative 0.5 equals to, just let me refer to that area. What was that area? It was 0.1915. Coming back 0.1915. So I write here 0.1915. Now this area, the red area is 0.1915, and we also know that the whole red plus blue area is going to be 0.5. So we will write from z equal to 0 to extreme left tail equals to 0.5. Therefore, area from z equal to negative 0.5 to extreme left equals to 0.5 minus 0.1915. Let us work it out. 0.5 minus 0.1915. 0.5 minus 0.1915. Then that gives you 0.3085. 0.3085. And finally we will conclude, therefore probability that returns will be below 9%. I'm sure it is 9%, right? Yeah, returns will be below 9%. Returns will be below 9% equals to 30.85%. That's your final answer. Just in case if you haven't written, I'm giving you time, quickly take note of this whole thing. The whole solution along with the required area given over here, I'm presenting to you. I'll show you another alternate way of presenting this solution. As I said, I'll be giving you another way to approach this. So the question asked you basically, what is the probability that the returns will be below 9%? So what we can simply do is, below 9%, we first identify where would that 9% line come. It is at negative 0.5. Below 9% means we want the area from that line to the extreme left, correct? From negative 0.5 to extreme left. Logically, if I identify this area from positive 0.5 to extreme right, can we agree that this area and this area both will be same? Can we agree that this both area will be same, because again same logic, the curve is symmetric to the center. So what will be the probability of returns from, or I would say probability of returns below 9%? We can simply find the area under normal curve from z equal to 0. But don't go to the extreme left now, because if you are tracing z equal to 0, 0.5, from z equal to 0.5, if you are tracing a positive 0.5, and if you come to the left tail, what will be a problem? You will be getting this area, that is from here to this part, which will not be the required area. We want this particular area only. So from z equal to 0.5 to the extreme right tail will be the same area as z equal to negative 0.5 to the extreme left tail. Both will be same. Now which version of z table should we refer? Look at this. The first table that I have referred was z table, area under normal curve from 0 to z. Through this we can compute the required probability. Already we have computed. I am just giving you another approach. We refer the other table of z, cumulative area below z, that is left tail area to z, left tail area. We don't want left tail area over here, we want the right tail area. So what we do, we move to the cumulative area above z, that is right tail area to z, and we want which z value? Z as 0.50, right? Look at what is given. Look at what is given over here. It is directly giving you the probability 0.3085, correct? It is directly giving you probability. Look at the junction. It is 0.5 and 0.00. So this junction is giving you the probability as directly 0.3085 or 30.85%. So I am sure you understood that. Okay. Now what if we would have observed the other area? So let me take you to the previous table and look at what is the value given over here for the same z equal to 0.5. So 0.5 and 0, this junction will give you probability as 0.6915. Now what is this probability 6915? Do you know? If I bring you back from z equal to 0.5 to the extreme left, the probability is 0. How much it was? 0.6915. This one. Let me mark that. 0.6915. So if it is 0.6915, that is the area from z equal to 0.5 to the extreme left. But we want the probability of returns below 9%. So it is the opposite side what we are looking at. So it is going to be 1 minus 0.6915. So 1 minus 0.6915 will give you the other probability, that is 0.3085 or 30.85%. This is how we arrive at that other part, which still gives you the same result, that is what? 30.85%. Are we clear with that? Now I could see some students have written the answer for probability for returns above 9% as 80.85%. It will be incorrect. Why? Which will be the required area if I have to find? See, don't just blindly take that. You know what you are doing? Those who answered 80.85% for area above that 9%, they have simply added 50% to this. You cannot do that, guys. You cannot add 50% to this. This is a common silly mistake that students end up making. Always keep patience and you look into which area we want to plot. So when the question is asking, wait. Okay, here it is a printing error. Let me rectify. It should not be below, it is above. So probability that the returns will be above 9%. How will you trace that? Tell me, how will you trace that? First you find the Z value for 9%. We have already found the Z value for 9%, correct? Z value for 9% is what? Negative 0.5. So here we identify negative 0.5 is coming at what place? Negative 0.5 is coming at this place. Okay, let me draw it properly. Negative 0.5, and we want which area? Tell me, we want which area? The probability that the returns will be above 9% means all the area to the right. So all the area to the right, that means we want this entire area. So from Z equal to 0, and this whole area, this is going to be 0.5, and this particular area, the area of this strip, you know how much that is going to be? That is going to be, we have worked out, right? It is this area, 0.1915. So this one, this area is 0.1915. So you tell me now, what will be the probability that the returns will be above 9%? Probability that the returns will be above 9% will be 0.5, that is this particular area, plus 0.1915. So the final answer will be 0.6915. Correct? So let me write that for you, and you can also write it along with me. So I would write area under normal curve from Z equal to 0 to Z equal to negative 0.5 is 0.1915. Area from Z equal to 0 to extreme right equals to 0.5. Therefore, cumulative area from Z equal to negative 0.5 to the extreme right equals to 0.1915 plus 0.5, that is equal to 0.6915. Finally, we can conclude, therefore, probability that returns will be above 9% equals to 69.15%. That's your final answer. In case you haven't written, so now what we do is we observe what all parts we have answered in this particular example. It asked you probability that the returns will be below 9%. We have answered that first part. Probability that the returns will be above 9%, that part also we have answered. Let me put that numbering over there so that there is no confusion at all. The numbering properly over here. This is the answer for the second part. Probability that the returns will be above 9%. And what is the third part asking you? Probability that the returns will be below 3%. So the way you have attempted this one, that is the probability that the returns will be below 9%, in the same style you are going to answer that part. So let us answer that. So this is not above. Oh, there are some typing errors over here. The question has asked you below, right? Below. And this is the third requirement. Probability that the returns will be below 3%. Let's read the question again. What it is asking, what is the probability that the returns will be? Look at this, this is below 3%. So below 3%. So let us first do one thing systematically. We find what the Z values for 3% returns. Okay. So I will first write Z equals to x minus mu divided by sigma. So that is 3 minus 15 divided by 12, right? Oh, this is going to be what? 3 minus 15 will be minus 12. Minus 12 divided by 12 will be minus 1. We got a round figure over here, minus 1. And we have learned what will be the probability when Z value is minus 1. We already know that. We have dealt with this kind of situation earlier, but let us still refer to the Z table this time. And what we do now, for this the Z value is coming to minus 1, right? So I focus on this normal curve and I identify where would negative 1 come. Suppose this is the point where I write minus 1. Okay, we want the probability that the returns will be below 3%. For 3% we have this part. So what we now do, we identify the probability of this region. We want the probability of this region, this blue shaded, right? If we want this probability, what we can do? We can find the area from 0 to minus 1 and then from 0.5, that is the whole area, we can subtract that. So let us first do one thing. The red area what I am marking over here is not your requirement, but through Z table you will be able to find that area first. So what I am going to do, I will write here area under normal curve from Z equal to 0 to Z equal to 1 is given as. So let us do one thing. Let us refer the first version of Z table where it is area under normal curve from 0 to Z, and Z value this time is exactly 1. So exact 1 over here. Look at this. So the required probability over here will be 0.3413. So when Z value is exactly 1.00, the probability comes to 0.3413. So I get back to this line area from z equal to 0 to z equal to 1. Basically we are talking about this red color area, this area we are talking about. We are talking about that red area which is given as 0.3413. Therefore, area under normal curve from z equal to -1 to extreme left will be 0.5 minus 0. How much it is? 3413. That is equal to, so let us subtract and find the area. That is 0.5 minus 0.3413. The area that you get is 0.1587. 0.1587. So you know what we did? We have taken the area, that is red plus blue taken together is 0.5. Red alone is 0.3413. So blue alone will be, it will be 0.1587. So what we are now concluding, that therefore probability that the returns will be below 3% will be 15.87%. Final answer is probability that the returns will be below 3% is 15.87%. So let me first of all give you an opportunity, in case you haven't written this, yet another way to answer this particular question. How you can answer this? Simply identify that you pick the right area. So let me remove this drawing, or let me separately draw a curve. I might not be drawing it very nicely, but still let me give a try. Something like this. This is the center. Okay. I in fact identify this is 0, this is 1. Correct. We want the probability that the returns will be below 3%. But because z values are always to the positive side, so this blue area, this blue area and this area, this blue area, can we agree that both will be same? They both will be same, correct or not? So now what we can do, for z being 1, positive 1, just find the area to the extreme right, correct? Area to the extreme right, it will give you area from z equal to 1 to the extreme right, which will be same as the area from z equal to -1 to the extreme left. Both the areas will be same. So let us observe that area. Okay, so I am referring to the z table where I get from z to the extreme right. Now this table is the left tail area. We want the right tail area. So let us move on to the next one, the right tail area. And we want from where? From z equal to 1. So simply go to the z equal to 1 value. Look at this, z equal to 1. What is the probability given over here? The final answer of this probability itself is going to be this one, that is 0.1587. Final answer will be 0.1587. That is what we have concluded over here already. So suppose that kind of Z table was given to you, you would have directly identified that this probability is 0.1587. So this is also 0.1587, 15.87%. Correct. So this is done. So I'm sure you understood this. I don't have to separately present for you so that you write it down. You know that second part, whatever I have discussed, just an alternative way. The final answer you have already noted as 0.1587 or 15.87%. So now what is left over in the question? So we have answered the third part as well. Now the fourth part is asking you what is the probability that the returns will be negative. Very simple. Probability that the returns will be negative means the returns will be below 0. So x value this time will be 0. Negative returns means it is below 0, correct? So what you do? The last part. So yeah, so this heading will be the fourth requirement. Probability that the returns will be negative. Very simple. What I am going to do? I am going to consider the z value over here based on x being 0. So I will write z equals to x minus mu divided by sigma, that will be 0 minus 15 divided by, so sigma is 12. So it is what? Minus 15 by 12, it will give you what? Negative 1.25. Negative 1.25, where we can plot negative 1.25. Look at this. Assume that the negative 1.25 value comes here. So what I'll do? This is the required area. This blue area is the required area. How do we find? We first do one thing. We identify this strip, that is the red area. So that will be area from z equal to 0 to z equal to negative 1.25. Okay. So I will write this. Area under normal curve from z equal to 0 to z equal to, you can write 1.25 or negative 1.25, it's going to be one and the same. I would write is given as, is given as. Now how do you write is that area? Let us go to the Z table, that is we want precisely this Z table, that is this Z table, that is area under normal curve from 0 to Z. So 0 to Z value, where Z value is 1.25. So let us identify 1.2. 1.2 is over here, and for 1.25 we have to take the column heading as 0.05. That's over here. So let us make the junction. So 1.2 and 0.05. So at the junction, what area you find? At the junction, what area do you find? It is the combination of these two, right? So it comes to this particular cell that gives you 0.3944. So look at this, we have exactly found this particular area from 1.2 and 0.05 junction. So the area is 0.3944, that is the required area. What is this 0.3944 area? It is the area from z equal to 0 to z equal to negative 1.25, and that is given as 0.3944. 0.3944. Now, do you know it is this red color area? It is this red color area which is 0.3944. It is a red color area, but we want blue color area. So we have to find the blue color area, which will be from z equal to negative 1.25 to the extreme left. So we will say area from z equal to negative 1.25 to the extreme left equals to 0.5. Do you know what is 0.5? 0.5 is the red area plus blue area, that is whole of this area. Red plus blue both taken together is 0.5. So what will be the blue area? From 0.5 you simply subtract 0.3944, and what do you get? Work it out. 0.5 minus 0.3944, you get 0.1056. And we conclude below that, therefore the probability that the returns will be negative equals to 10.56%. That's your final answer for the last part of the question, 10.56%. That means this blue color shaded area, this area is 10.56%. You can write it 0.1056 or 10.56%. So that is the required area. So in case you have yet to write down this whole thing, I am displaying the whole content together, this part, so that you can comfortably write it down. This one, yeah, please note it down in case you haven't noted, and once you note it down, it will be end of this particular session.